In the previous videos, we have completed and provided reachability on all the routers within ISP1 and ISP2. In this video, we will be configuring MPLS both in ISP1 and ISP2. The configuration will be step-by-step by following the list of tasks on the screen. We will start from the basic MPLS configuration: LDP authentication and session protection, LDP filtering and synchronization, then disable TTL. Let us start with the basic MPLS configuration. Enable MPLS on all the links within ISP1 and ISP2. Use the loopback address of each router as the LDP router ID, then set the label range on every router. Use MPLS LDP autoconfig in IGP on both ISP1 and ISP2 to activate MPLS. Let us begin with ISP1, then enable MPLS using the commands on the screen. The commands are straightforward. Let us begin with XE Router 1 and continue until XE Router 5. Here, we are activating MPLS under the IGP process. Another option is to enable it manually per interface. XE Router 1 is done. Issue the command: Show MPLS interfaces to verify the activated interfaces with MPLS. Proceed and continue with the other routers in ISP1. We are done with ISP1. Let us do some basic verification using the commands on the screen. Issue the command. Show MPLS interface to verify that LDP is already activated. Refer to the screen for the other verification commands. Issue the command. Show MPLS LDP neighbor to verify the LDP neighbors in each router. Then input the command, show MPLS forwarding table to verify the content of label forwarding information base. To verify the connectivity, let us conduct ping and tracer route from XE router 1 going to XE router 5. MPLS is activated on all the routers in ISP1 and LDP neighborship is successfully established. We can also see a labeled packet based on our tracer route. Let us now proceed with ISP2 and start with XR router 1. Refer to the commands on the screen. The commands in XR router is almost identical with XE routers, except that MPLS LDP must be enabled globally. Proceed with XR Router 2, then continue the configuration until XR Router 5. Verify if MPLS is activated on the interfaces, then check the LDP neighbors and forwarding table in each router. ISP2 is already done, and MPLS is activated on all the links. LDP neighborship is also established with a labeled path based on the tracer route. To continue, let us configure LDP authentication for additional security on all the routers in ISP1 and ISP2. For the task, configure authentication for the LDP peering in ISP1 and ISP2. Use the password Network Lab. Let us begin with XE Router 1. Here, we will use an access list and allow the router ID of LDP neighbors to be authenticated. Refer to the commands on the screen. First, configure the router to require password and check the output. After issuing the command to require password, we can see that the LDP neighbors went down immediately. Then for any unmatched sessions, configure a fallback password. Let us proceed and continue the configuration of LDP authentication in ISP1. In XE Router 2, upon configuration of the matched authentication password in XE Router 1, the LDP neighborship comes up. Proceed with the other routers and configure the required LDP authentication password. LDP authentication is all set and matched in ISP1 and LDP neighborship in each routers are back. We can now proceed in ISP2. In ISP2, under MPLS LDP configuration, we will enable and set the password manually to each LDP neighbor. Refer to the commands on the screen. Use the clear text password, Network Lab for each LDP neighbor. Let us begin with XR Router 1, then manually set the LDP password on each neighbor. After the LDP authentication password is set, all the LDP neighbors went down in XR Router 1. Continue and apply the configuration on all the routers within ISP2. LDP authentication is complete within ISP2, and LDP neighborship in each router comes back up. We can now proceed with the next task. Next task, enable MPLS LDP session protection on all the routers within ISP1 and ISP2. With MPLS LDP session protection enabled, LDP session between two routers remains up if the link fails as long as the loopback is reachable. In XE routers, the commands is applied globally, while in XR routers it is applied under MPLS LDP configuration. Before we proceed with the configurations, let me show you what would happen if the link between XE router 1 and 3 fails. After shutting down the physical interface, the IGP and the LDP went down immediately. Let's unshut the port, then configure LDP session protection on all the routers. ISP1 is done. Before we continue, let us verify if the LDP session protection is working. As you can see, the IGP is down, but LDP is still up. Session protection is now working in ISP1. Let us continue and proceed with ISP2. Enable session protection under MPLS LDP on all the XR routers. LDP session protection is configured within ISP2. Let us verify and check if it is working in XR router 1. Shut down the physical interface facing XR router 3. As you can see, if the link is up, the session protection state is ready. When it is down, the state is protecting. With this, LDP session protection is now working both in ISP1 and ISP2. Next task, disable TTL in ISP1 and ISP2, especially in PE routers for additional security. With TTL disabled, TTL packets from customers are not copied to MPLS labels, and it will not appear on the tracer route. I will show the effect later on in VRF and PE to CE configurations. For now, we will just apply the configurations on all the routers. Refer to the commands on the screen. The configuration is applied globally, both in XE and XR routers. Let us begin and configure all the routers. Both ISP1 and ISP2 are done. We can now proceed with the next task. Next task, enable MPLS LDP label filtering within ISP1 and ISP2. For the configurations, we will create an access list and allow only the loopback IP of the routers, then apply under MPLS LDP. Refer to the screen for the commands. Before we proceed with the configurations, let me show you the LDP forwarding table by default. Without label filtering, even the transit networks are present in the table. Now, let us configure LDP filtering in ISP1 and ISP2. After applying the filter, we can see that only the loopback IP address of the LDP neighbors are present on the LFIB. Copy and apply the commands to the remaining routers in ISP1. LDP label filtering is done in ISP1. We can now proceed with ISP2. The same with ISP1, create an access list, then permit the loopback IP address of each router in ISP2 and apply under MPLS LDP. MPLS LDP filtering works in XR router 1. Continue and proceed to the other routers in ISP2. Label filtering is already done in ISP2. Let us proceed with our last task in MPLS, which is LDP synchronization. Label filtering is already done in ISP2. Let us proceed with our last task in MPLS, which is LDP synchronization. With LDP synchronization, if the link between two LDP neighbors encounters an error or problem, the IGP will put high metric on that links. In our lab, we will just enable LDP synchronization in ISP1. The command is applied under the OSPF process. Let us begin with XE-Router1. LDP synchronization is done. Let us test and check if it is working in XE-Router1. To test, let us create an access list, then deny TCP port 646 for MPLS LDP in XE-Router1 facing XE-Router3 link. In the OSPF database of XE-Router1, the metric on the link facing XE-Router3 is 1. Let us create an access list to drop LDP port. By default, if the LDP neighborship between XE-Router1 and 3 is up, the traffic will traverse on it. Let us apply the access list on the interface facing XE-Router3. LDP synchronization is working. The metric on the link between XE-Router1 and XE-Router3 increases, and the LDP traffic is dropped and traversed to the other available link. With this, our MPLS network is done and working both in ISP1 and ISP2. To summarize, just like building our IGP in ISP1 and ISP2, we started our MPLS topology by building from the basic configuration, then security and optimization. Our network is now ready to activate the different services like L3 and L2 VPN. I hope that this is informative to you, and thank you for watching.